Now, in this video, we're going to talk about how to add or subtract polynomials. In previous sections, we talked about something called a monomial. So if you recall what a monomial is, for example, 3x squared, that's called a monomial. What is a monomial? We multiply. Notice that operation is multiplication. When we multiply numbers and variables, and that's called a monomial. For example, 3 times x squared, it's a monomial. The operation multiplication between them is omitted. And let's take a look at another monomial, say 5x squared. And if we put a plus between them, we're adding these two monomials. But if you look at them together, when we add these two, what we got is called a polynomial, because there's more than just one monomial. So if there's more than one monomial, and that's polynomial. And polynomial, we also call each of the monomials a term. So for example, 3x squared, it's our first term, and 5x squared, it's our second term. So we got two terms. So polynomials has at least 2 terms, or 3, 4, 5, or more terms. Okay, so let's look at how we add these two monomials. First of all, not all the monomials can be added. With most of the numbers, say a fraction plus a fraction, we can always add them. Or even a fraction plus a decimal, we can also add them. Or whole number plus a fraction, whole number plus a decimal. But when we have monomials, because we're mixing numbers and variables, we may not be able to add them. So the first step, when we do addition or subtraction, we must verify they are like terms. If they are not like terms, we cannot add them. So let's take a look at these two here, 3x squared and 5x squared. And when we check, see if they're like terms, we look at the variables. We don't look at the numbers in front of them. So variables, they have to, when we say like terms, they have to match. They have to be exactly the same. We call them like terms. Not only the letter is the same, say x and x, but also their exponents, say squared to squared. So we call them like terms. And if they are like terms, so these two terms, first term, second term, because they have the same variables and exponents, we call them like terms. Now we can add them. And when we add them, we don't change the variables. The variables x squared will stay. X squared plus x squared still be x squared. Think of x squared as like dollars. Say $3 plus $5, or apples. 3 apples plus 5 apples. You still get you get how many apples? $3 plus $5, you get how many dollars? And so here, all you have to do is to add the numbers in front of them. So it's like 3 plus 5. That gives us 8. So this 8 comes from adding 3 and 5. 3 plus 5 equals 8. And we put that number in front of the variable. So make sure you don't change x squared to x to the 4th. X squared always stay. Okay, but when we do multiplication, we also learned how to multiply, and that's completely different. When we multiply them, we do have to change the exponents. So for example, 3x squared times 5x squared, and we multiply separately. And 3 times 3, we got 15. And x squared times x squared, by using the exponential rule, we keep the base x, we add exponents 2 plus 2, we get x to the 4th. But for addition, you don't do this separately. For addition, you copy the variables x squared. You only add the numbers in front of them. So multiplication and addition are completely different. So now we're going to, so this section here, we're not going to talk about multiplication. So don't worry about this in this section. And we're going to focus on addition. And now we can look at example. Say we have example 1, we can do 3L plus 5M minus 7N plus 2L minus 7M minus 3N. Now, when we do this question, we're going to try to get rid of the parentheses, get all the terms out of the parentheses. So each one in the parentheses is what we call a polynomial because there's more than just one term. So this is a polynomial and that's a polynomial. So we're adding two polynomials. Well, each of them this is a monomial, this is a monomial. So when you are adding polynomials, you're actually also adding or subtracting a lot of monomials. Okay, so when we do this, we try to get rid of all the parentheses. So first of all, I'm going to put because there's not a number in front of this pair of parentheses, I'm going to put a 1 in front of it, and it's 1 times. And there's not a number in front of this second pair of parentheses, we put a 1 times. So what we're going to distribute is this 1 to every term inside the parentheses, because 1 times anything is the other thing. So anything times 1 is it itself. So when we do 1 times 3L, we are still going to get 3L. And 1 times 5M, we still get 5M. 1 times negative 7N, we still get negative 7N. Now let's multiply this 1 with every term inside the parentheses using distributive principle. So we do 1 times 2L, that's 2L. And 1 times negative 7M, we get negative 7M, and 1 times negative 3, negative 3N. And now we are going to try to add or subtract them. This is similar to what we did before. And previously we only had like 2 terms or 3, not many as this many terms. And when you have 2 terms, you just have to look at the variables. Do they match? If they don't match, we just say cannot add. But if they match, we can add them. So here, if we look at all of them, they don't all match, but some of them match. So when we do this, we will find the ones who which match. When we say when I say match, I mean like terms. For example, 3L and 2L, they both have the variable L, so they're like terms. And 5M, negative 7M, they both have M, they're like terms. And negative 7N, negative 3N, they are also like terms because they both have N. So now we can do them separately. So there are 3 problems we gotta do. 3L plus 2L, using what we just reviewed. We keep the L, don't change the L. So like $3 plus $2, we get $5. So it's 5 L's. And 5M minus 7M, we can 5 minus 7, that gives us negative 2, and keep the letter M. Negative 7 minus 3, negative 10, and keep the letter N. We don't change the letter. Okay, so that's the first example. And when we get here, we have to stop because we cannot add terms that are not like terms. For example, this one we have L, M, N. They are not like terms. Okay, now next example, we're going to do a subtraction. So the first example is addition between these 2 polynomials. We can do subtraction. I can do 3L squared plus 5M minus 7N cubed minus 2L squared and minus 7N and minus 3N cubed. So in this case, we have subtraction between them. First, we're still gonna get rid of parentheses. So let's put a 1 in front of each pair of parentheses. So it's 1 times this and negative 1. Be very careful here. For the second pair of parentheses, because there's a minus sign in front of it, so we're distributing negative 1 to all of them. So let's do distribute principle. So 1 times 3L squared, we get 3L squared. And then 1 times positive 5M, we get a 5M. and then 1 times negative 7n cubed. We still get that. When we multiply negative number with these, it's going to change the signs. So for example, negative 1 times 2, we get negative 2l squared. Negative 1 times negative 7, we get a positive 7m. As you can see, negative sign is changed to a positive sign here. And then negative 1 times negative 3, we get positive 3n cubed. Again, the sign has been changed in front of 3. Now we can find the like terms and combine them. So as we can see, there's a L squared term and there's a L squared term right here. We have an M term, there's an M term here, and we have a n cubed. Now let's combine them. So 3l squared minus 2l squared, we do 3 minus 2, that's 1l squared. That 1 in front of l squared can be omitted. 5m plus 7m, that's 5 plus 7, this many m's, so 12m. And when we do the last one, negative 7 plus 3, negative 7n cubed plus 3n cubed, we do negative 7 plus 3, that gives us negative 4n cubed. And we take a look at our final answer. None of these are like terms. We can stop.